Good day, my dear friends. Today I'd like to propose for your attention a solving of a problem number 4. The scheme of this problem you see on this slide. We have inductor L1, capacitor C2, resistor R3 and capacitor C3 connected as it's shown in this scheme. We know also the parameters of each passive elements of this scheme, and we know the voltage. Voltage acts on inductor L1 and voltage acts on capacitor C3. To solve, we need to determine voltage on the capacitor C2, this voltage. To solve this problem, we will have to use the relationships between current and voltages of passive elements. You can see these relationships in this table. This table we will product in our lecture number 3 of topic Basic Concepts and Law of Electrical Circuits. First of all, we will set the conditional positive directions of currents in each branch of this scheme. For example, like it's shown in these arrows, I1, I2, and I3. When we have directions of each current, we already have voltages in each passive elements. And you might remember voltage and current on passive elements has some directions. We need to determine voltage UC2. This voltage, according to this table, this is a voltage on capacitor C2. We can found as 1 over C2. Do you see 1 over C in this formula? This is general formula. Times integral I2 over dt. We need to find I2 according to this formula, and then we can find UC2. Current I2 we can obtain from Kirchhoff's first law. For this node, we can write that 1I plus I2 plus sign and I3 minus sign. I3 is directed into this node, but I1 and I2 is directed to this node, plus this, and minus sign this. According to this equation, we can see that I2 is equal I3 minus I1. So we have to obtain I1 and I3. Current I3 acts in inductor L1, and according to this table, we can find it as, do you see this table? Current of inductor is 1 over L, 1 over L1 in our case, times integral UL over dt, UL1 dt in our case. Let's we substitute the input data of our problem. 1 over 5 5 is the inductance of this inductor L1 times integral 5 t power 2 t power 2 multiplied by 5 is ul1 dt. This integral is equal 5 over 5 t power 2 dt. T power 2 integral is 1 over 3 t on power 3, this formula. Current I3 acts in capacitor C3, and according to this table we can find this current as this formula. In our case, this is a capacitance C3 times du3 with respect by dt. After substitution our input data, we have 200 is a capacitance of capacitor C3, but it is microfarads. Microfarads is 10 in minus 6 power multiplied by derivative d 50 t power 4 with respect by dt. This is 10 minus power minus 3 times t power 3. Now we already have a value of current number 1 and current number 3, and now we can use our formula for determine I2. According to this formula, we can see that our current number 2 is minus 0.33 times t power 3. And voltage UC2 we can find as this formula. After substitution and calculation we obtain minus 825 times T4. This is voltage. Our problem has been solved now. Thank you for your attention. Goodbye, my dear friends.